I'm Hannah.
And I'm Sophie. And this is math.
Woo!
Let's do some vocabulary.
Tangent line is a line that touches one point on a curve. The slope of a tangent line gives you the instantaneous rate of change at that point.
Nice.
Thanks.
The derivative is the instantaneous rate of change at one point on a curve.
Yeah. Critical points are when the derivative of a function equals 0.
The problem. What is the slope of the tangent line to the curve f of x equals 3x squared minus 4x plus 2 squared, where x equals 2?
First you take the derivative.
Now you plug in 2 for x into the derivative, and you find that when x equals 2, the derivative is 144. This is a graph of the function and a representation of the tangent line at x equals 2. Let's do some vocabulary. So the point of inflection is when a function changes concavity. Concave up looks like this, and concave down looks like that.
The maximum value is when the function slope is equal to 0, positive slope changing to a negative slope. The minimum value is when the function slope is equal to 0, changing from a negative slope to a positive slope. The question, where on f of x is it concave up and concave down? Where is the inflection point?
Are you ready? The original function is x cubed minus 3x squared plus 3x. The derivative of that function is 3x squared minus 6x plus 3. The second derivative of the original function is 6x minus 6.
These are the graphs of f, f prime, and f double prime.
Alright, we know that the function is concave up from 1 to infinity because the derivative is, the slope of the derivative is positive, and because the double derivative is positive from 1 to infinity.
F is concave down from negative infinity to 1 because on f of x, let's go to f prime. Because on f prime, the slope is negative from negative infinity to 1. And because f double prime is in the negative region.
Point of inflection.
Okay, now go.
The point of inflection is at 1, 1 because in the graph of the derivative, the slope is changing from a negative slope to a positive slope at the point equals 0. And then for the double derivative, the function is changing from negative to positive at 1, 1. Hi, I'm Sophie.
I'm Hannah.
And this is math.
Good screen. So, the intermediate value theorem states that with a continuous function, all x values must exist between points a and b in the interval a to b, and a y value must exist for each x value in that interval.
So basically, there is a y value for every x value in A to B.
So the mean value theorem states that in a continuous and differentiable function, there is a point C in the interval AB where the instantaneous rate of change is equal to the average rate of change.
So basically, there's a point where the average rate of change is parallel to that certain points
instantaneous rate of change, and that point exists on. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t 0 less than or equal to t less than or equal to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table. The question is there a time t between 2 less than or equal to t less than or equal to 4 at which c prime of t equals 2? Justify your answer. So, yes, because the MBT, the mean value theorem, states that if a function is differential and continuous, then some value t, where c prime of t will equal to 2 ounces per minute, because of this.
4 minus 2 under 12.8 minus 8.8.
Boom. Found in the table.
And it equals 2.
Boom.
Woo! 3, 2, 1.